In this video, I'll demonstrate how to perform the Mann Whitney U-test. This test is utilized when we've got two groups that we wish to compare on a single outcome. And this outcome is typically either ordinal scale data or numeric data that is skewed and does not meet the expectation of normality. And so this is the non-parametric alternative to the independent t-test. So in this case, we're going to be using for our independent variable gender, broken into male and female categories. And then we're going to look at some ordinal data where the individuals are asked to rank the importance of getting a regular night's sleep. And they ranked it from very important to unimportant. And so we want to try and determine if there's a difference based upon gender in how they rank the importance of sleep. And so our sleep rank is going to be our dependent variable and gender is going to be our independent variable. So our null hypothesis would be that there would be no difference in the median value for each group of male and female. Because we have ordinal scale or non-normal numeric data, we cannot use a mean to compare those groups as far as the central tendency of the groups. So we now use the median to make this comparison. And so the Mann Whitney U is essentially interpreted much the same way we would an independent t-test. We'll have a statistic that we need to interpret, a p-value associated with it, and then we're also going to be able to look at an effect size. So let's go ahead and run this comparison. So we're going to go to the analysis menu. We're going to find non-parametrics and then the Mann Whitney test. And so we want to first of all indicate our dependent variable, which in this case, as we mentioned, is going to be sleep rank. Click confirm. And then our independent variable is going to be, in this case, gender. So this has to be a two-category variable in order for this analysis to work. So then we click confirm and click calculate. And we're first going to go to our raw output here. And so this is a pretty bare bones output that we're given. And so we're given our sample size, we're given the statistic for the Mann Whitney, which is also interpreted as a z-score. And then we have the p-value associated with that z-score. And then we've got a median value for the male group and a median value for the female group. And so we can see here as we look at the p-value, we can see that this is not less than 0.05. So we would not reject the null hypothesis, and we would say that there does not appear to be a significant difference in this sample between sleep rank in males and females. We can see, however, this is trending towards significance, so that sometimes that's important to note. One thing we can do as far as looking at the effect size, we can use the z-score value, and then we would take that value and divide it by the square root of the sample size. So we would take the square root of 28, which is our sample size, which works out to be 5.29. We then divide that into 1.8, and we disregard the minus sign. And that will give us a value of 0.34. And so our criteria for having a small, medium, and large effect size, so for anything less than 0.1 would be considered to be a small effect. Anything between 0.2 and 0.4 is considered to be a medium effect. And then anything greater than 0.5 is considered to be a large effect. So that 0.34 value we came up with as we did that calculation would be considered a medium effect. And so we have a non-significant result and a medium magnitude of effect. So this very often triggers in our mind that perhaps we need a larger sample size, perhaps we don't have enough people to be able to see a true difference if there is one. And so repeating this with a large sample size may yield a different result, or it may not. But there is a moderate magnitude of effect with a non-significant difference. And so we can conclude, in this sample at least, there does not appear to be differences in how sleep is ranked in importance between males and females. So hopefully you found this video useful, and good luck using this in your own research.